Hello dear students, today we are going to discuss some questions from binomial theorem. These are last year questions and you need thorough concept and practice to solve these questions. Okay, let's start the first question. The first question is, if sigma r is equal to 0 to 5, 11C2r plus 1 by 2r plus 2 is equal to m by n. GCD of m and n is 1, then m minus n is equal to. We have to find out m minus n. So here we are going to apply the principle NCR is equal to n by r, n minus 1 CR minus 1. This is the principle that we are going to use here. So if you check the question, if we multiply in the numerator and denominator with 12, this whole term we can write with this principle as 12C 2r plus 2. So this whole sigma will be 1 by 12, sigma r is equal to 0 to 5, 12C 2r plus 2. So when you check this summation again, it is the sum of all the even coefficient except NC0. So the sum of all even coefficient, we know the value is 2 raised to n minus 1. But here the zeroth coefficient is not there. So we have to subtract 1 from the 2 raised to n minus 1. So here it will be 2 raised to 12 minus 1 minus 1. Okay. So that is what has been written here. So this will become 2048 minus 1 by 12, that is 2047 by 12. So if you check, the common factor between these two numbers is only 1. So our m is equal to 2047 and n is equal to 12. So m minus n will be 2035. So 2035 is our final answer. So next question. Let alpha, beta, gamma and delta be the coefficients of x raised to 7, x raised to 5 and x raised to 3 and x respectively in the expansion of x plus root x cube minus 1 the whole raised to 5 plus x minus root of x cube minus 1 the whole raised to 5 x greater than 1. If u and v satisfy the equation, two set of equations are given, then the value of u and v. We have to find out the value of u and v. So when you check the binomial expansion of x plus root under the root of x cube minus 1 plus, again here the difference is, here it is plus and here it is minus. So when you are taking summation of these type of, means here it is plus and here it is negative, is what happens is the odd power of the root will get cancelled and the even terms will double. So what happens here is 2 into all the even terms will come. All the even terms will come. 2 into 5C0 x raised to 5 plus 5C2 x cube, then the root term is coming, 5C4 x into again the root term is coming. So when you solve this, you will get 2 into x raised to 5 plus 10 into x raised to 6 minus x cube plus 5 into x raised to 7 minus 2x raised to 4 plus x. So now we can equate the coefficient of x raised to 7, x raised to 5, x cube and x. So from here our alpha will be equal to coefficient of x to the power 7. So 2 into 5, that will be 10. Beta is coefficient of x to the power 5. So it will be 2. Beta is equal to 2. Then we have gamma, that is coefficient of x cube. 2 into 10 into minus 1, that is minus 20. Then we have delta. Delta is equal to coefficient of x. 2 into 5 into 1, that will be 10. So when you substitute these values in this equation, we get 10u plus 2v is equal to 18 and minus 20u plus 10v is equal to 20. So these are two equations with two variables. When you solve them, you get the value of u and v as 1 and 4. So what we have to find out is u plus v. So u plus v is equal to 1 plus 4, that is equal to 5. So 5 is our final answer, option number 1. The next question is, if sigma r is equal to 0 to 30, r square 30 cr the whole square by 30 cr minus 1 is equal to alpha into 2 to the power 29. Then alpha is equal to, we have to find out the value of alpha. Taking the term in the summation, I am going to rearrange it. So 30 cr square, here I have split into 30 cr into 30 cr. So now 30 cr by 30 cr minus 1. This will be 30 minus r plus 1 by r. Okay. So again this 30 cr will be 30 by r into 29 cr minus 1. Okay. Using this, we got, when we substitute this back in this one, we will get 30 into 30 minus r minus 1 into 29 c r minus 1. So rearranging it, we get this one. So here again, if you check, 1 minus r is there. So using the expansion of this, we can again 29 by r minus 1 into 28 c r minus 2 we can write, so that we can cancel this r minus 1 and r minus 1. So we got this. Okay. And now substituting back in the sigma term, we get sigma 29 cr minus 1 minus 30 into 29 is there, and again 28 cr minus 2. Those are the summation of two binomial coefficient. So this will be nothing but 2 into 2 raised to 9, and here it will be 2 raised to 28. So in the option, in the question, we have 2 raised to 29. So we have to convert this 2 raised to 28 into 29. That is, we can convert this 30 into 15 into 2 and take this to 2 raised to 28 into 2 raised to 29. So what we get is 30 into 30 into 2 raised to 29 here, and 15 into 29 into 2 raised to 29 here. Take 2 raised to 29 common and solve whatever is inside the bracket. So we get 465 into 2 raised to 29, that is equal to alpha into 2 raised to 29. So we get alpha is equal to 465. So 465 is our answer. So the next question is, the sum of all rational terms in the expansion of 1 plus 2 raised to 1 by 3 plus 3 raised to 1 by 2 the whole raised to 6 is equal to. So here the expression for the general term of this expansion is t r plus 1th term is equal to n factorial by r1 factorial, r2 factorial, r3 factorial into first term a raised to r1 into b raised to r2, that is the second term, third term c raised to r3. So here for our given question, this general expression will become n factorial, instead that will be 6 factorial by r1, r2, r3 factorial. Here our first term is 1, so 1 raised to r1, second term is 2, so 2 raised to r2 by 3. The third term is 3, so 3 raised to r3 by 2. Here one thing you have to note is, in both the cases, r1 plus r2 plus r3 will be equal to n. Here in our case, it will be r1 plus r2 plus r3 will be equal to 6. Okay, so when you check these r1, r2, these coefficients or the powers of these 1, 2 and 3, when these rational terms will come, when for 1 any value can come between 0 to 6. For r by 3, the possible values of r2 will be 0, 3, 6. So r3 it will be 0, 2, 4 and 6. Okay, so these are the possibilities. For r1 it can be anything from 1 to 6. Okay, so taking each possibilities, the sum should be 6. So r1, r2, r3 are here. So the possible values are set here. So we get 7. 1, 2, 3, 4, 5, 6, 7 set of values for r1, r2 and r3. So once you get all these 7 set of values, you substitute it back in the general term to get the 7 terms. Okay, so 7 terms, you substitute these values, you will get these, and summation will be 612. So that final result will be sum of the rational terms will be 612. So the next question, if in the expansion of 1 plus x the whole raised to p into 1 minus q the whole raised to q, the coefficient of x and x square are 1 and minus 2 respectively, then p square plus q square is equal to. So we have to find out p square plus q square. So for that we have to find out the value of p and q from the expansion. Okay. As here in the question, only x and x square coefficient has been asked. So we can expand the given binomial expansion term because only the first 2-3 terms are required. So when you are expanding 1 plus x the whole raised to p, you get 1 plus pc1 x plus pc2 x square plus etc. The remaining we don't need actually. So the second will be 1 minus q the whole raised to q will be 1 minus, because minus is coming. So 1 minus q c1x plus q c2 x square, again negative. So we are only interested in the coefficient of x and x square. So no further terms are required. So converting means this c1 pc2 qc1 qc2, we get these. So now we have to equate the coefficient of x. What are the coefficient of x? Then these terms are multiplied. Here it will be p and here it will be minus q. So equating the coefficient of x, we get p minus q is equal to 1. That is we already given in the question. Now equating for the coefficient of x square. So directly coefficient of x square, p into p minus 1 by 2 is there, q into q minus 1 by 2 is there. Now multiplication of pq and minus qx. So that will be p into p minus 1 by 2 plus p into p minus 1 by 2 plus q into q minus 1 by 2 minus qp. That is also there. The total will be equal to minus 2 given in the question. So you have two equations and two variables. Solving this, you get the values of p and q as 3 and 2. What has been asked? We has been asked to find out p square plus q square. So that will be 9 plus 4, that is 13. 13 is your answer, option number 2. So the next question is, for some n not is equal to 10, let the coefficient of 5th, 6th, 7th term in the binomial expansion of 1 plus x the whole raised to n plus 4 be in AP. Then the largest coefficient in the expansion of 1 plus x the whole raised to n plus 4. Here they have been asked to find out the largest coefficient in the expansion. To find out the largest coefficient, we need to know our power, that is n plus 4. Or in short, we have to find out n. So the 6th, 5th, 6th, 7th term in the binomial expansion will be n plus 4 c4, n plus 4 c5 and n plus 4 c6. So, and it is said that they are in arithmetical progression. That means the middle term will be the average of the sum of first and the third term. So using this principle, we have n plus 4 c4 plus n plus 4 c6 is equal to 2 into n plus 4 c5. What I am going to do here is I am going to add 2 times n plus 4 c5 to the right and to the left. So n plus 4 c4 plus n plus 4 c5 plus again n plus 4 c5 plus n plus 4 c6 is equal to, here I am going to add it twice, so it will become 4n plus 4 c5. So this will become n plus 5 c5, okay, plus this will become n plus 5 c6 is equal to 4n plus 4 c5. Again these two will become n plus 6 c6 is equal to 4 n plus 4 c5. So this is what you get. And solving this, you will get n is equal to 3 and 10. already in the question it is said n naught is equal to 3. So n is equal to 3. N naught is equal to 10, so n is equal to 3. So that means n plus 4 is 7. So you have total 8 terms in your binomial expansion. So if you have 8 terms, then the middle term will be the fourth and the fifth term. So the greatest coefficient will be of fourth and the fifth term, that is 7c3 and 7c4. So that both the coefficient will be equal, and that will be equal to 35. So option number 3 is your answer. So the next question, suppose A and B are coefficient of 30th and 12th term respectively in the binomial expansion of 1 plus x the whole raised to 2n minus 1. If 2a is equal to 5b, then n is equal to. So it is given that 30th and 12th term respectively are in the relation 2a is equal to 5b. So what is our 30th and 12th term? 30th term is 2n minus 1 c29 and 12th term is 2n minus 1 c11. So given it is in the relation 2a is equal to 5b. So it is 2 into the a, 5 into b. Now expanding, we get this. So this term and this term will cancel. Cross multiplying these two, we get this. Okay, so I am going to multiply both the sides with 6. Why I am doing this is because 6 into 5 will become 30. 30 into 29 factorial, I can write it as 30 factorial. Here again 6 into 2 will become 12. 12 into 11 factorial can be written as 12 factorial. So this is what we get. So in this, looking at the format, either 2n minus 30 factorial will be equal to 12 factorial, or 30 factorial will be equal to 2n minus 12. So equating either way, you can find n is equal to 21. That means either you can do 30 is equal to 2n minus 12, or you can equate 12 is equal to 2n minus 30. So either way you will get n is equal to 21. So answer is 21, option number 3. So the next question is, let the coefficient of 3 consecutive terms tr, tr plus 1 and tr plus 2 in the binomial expansion of a plus b the whole raised to 12 be in GP. And let p be the number of all possible values of r. Let q be the sum of all rational terms in the binomial expansion of fourth cube of 3 plus third cube of 4 the whole raised to 12. Then p plus q is equal to. So this problem we can approach in two sections. The first section is, it is given 3 terms in a binomial expansion of this a plus b the whole raised to 12 is in geometrical progression, and p be the number of possible values of r. Okay, let's consider that first. So it is given the 3 terms are in GP. So in that means ratio of these consecutive terms should be equal. So the ratio of the second term to the first term, that is written here, second term to the first term, and the ratio of the third term to the second term, that is this, should be equal. So by the principle, you know that 12 CR by 12 CR minus 1 will be equal to 12 minus R plus 1 by R. Similarly, 12 CR plus 1 by 12 CR will be equal to 12 minus R by R plus 1. So using this, we get this. Okay, solving this, no possible solutions of R we are getting. That means no possible values of R. That means these terms are not in geometrical progression. So P will be 0. P will be 0. So the first section we have solved. Now moving on to the second section. So we have to find the sum of the rational term in this expansion. So the general term will be tr plus 1 is equal to 12 cr into 3, that is the first term, 3 raised to n minus r. So here it is 12 minus r by 4 because it is the fourth root. into the second term is third root of 4. So 4 raised to r by 3. So this r value will lies between 0 to 12. So looking at these 3 and 4, we can say that the r value must be multiple here. For 3, the r value must be multiple of 4. That is 0, 4, 8 and 12. Looking at this 4, r values should be 0, 3, 6, 9 and 12, right? Yes. So what are the common values here when we check? 0 and 12. So these are the common values. Only for 2 terms this will be having rational values. So that is for the first term and for the 13th term. So substituting these r values back, we have the sum of first and the 13th term. So this will be our first term and this will be our 13th term. So we get q is equal to the sum, that is 283. So what we need to find out is p plus q. P is 0 and q is 283. So p plus q will be 283. So our answer is option number 1, 283, not option number 2. So the next question, the coefficients of x to the power p and x to the power q in the expansion of 1 plus x the whole raised to p plus q are. So we have to find out the coefficient of x to the power p and x to the power q. So the general term we write t r plus 1 is equal to p plus q cr into 1 to the power p plus q minus r into x to the power r. So this term is important, x to the power r. So when do we get x to the power p and x to the power q? When we put r is equal to p and q. When we put r is equal to p and q, we get x to the power p and x to the power q. So at that time, what are the coefficient we are getting? When we put r is equal to p, we get p plus q cp. When we put r is equal to q, we get p plus q cq. Okay, so by the principle, we have p plus q cp as p plus q factorial by p factorial into q factorial, that is p minus q minus p, that is q factorial. P plus q cq will be again p plus q factorial by q factorial into p plus q minus q factorial, that is p factorial. So looking at it, both the coefficient are equal. Both the coefficient are equal. So the correct answer is option A, equal. So the next question, if the sum of the coefficient in the expansion of a plus b the whole raised to n is 4096, then the greatest coefficient in the expansion. So again, greatest coefficient has been asked. If you are asked to find out the greatest coefficient, definitely you have to know the power in the binomial expansion terms, that is n. So first you have to find out the value of n. So the sum of the coefficient of a plus b the whole raised to n is 4091. So how do you find out the sum of the coefficient? A and b, 1 plus 1 the whole raised to n, that is 2 raised to n. So 2 raised to n is given as 4096. From that you get n is equal to 12 because 2 to the power 12 is 4096. So if there n is 12 means you have 13 terms. So 13 terms means the middle term is the greatest one. So that will be 6 plus 1, the 7th term. So the 7th term will be, the coefficient will be 12c6. So that is 924. So the right answer is option number C, 924. So thank you. Practice more questions. More question means less errors and your confidence will be more. So for more such practice numericals and all, subscribe to Brilliant Kuwait. For physical classes, join us.